Hey everyone, welcome to topic number 19, simplify and evaluate algebraic expression. So now we're going to start talking about a little bit with algebra stuff. Okay, so a couple of things um, I want you to understand first. Number one, algebraic expression. Okay, what's considered as an expression is simply something made out of many terms. So I believe I used the example before where I have a rectangle, a triangle, and maybe a circle. Okay? Together, this is called an expression because this expression consists of three different terms. Okay? So the expression is just something made out of many terms. So what do we do with these expressions? We can combine them. Okay, we can combine the like terms. So remember, we talk about like terms are referring to terms with the same variable and the same exponents. Okay, got to have the same variable and the same exponent before you can combine them. All right. Combine like terms. Okay, I use this word a lot. Combine like terms means we will add or subtract. Okay, terms with the same variable and the same exponents. So it turns out when we actually combine like term, when you actually doing it, okay, when you actually add or subtract, you are only adding and subtracting coefficients, okay, and do nothing with the exponents, okay. So what's considered as an as so what's a coefficient? Okay, coefficient. There's actually, in my opinion, there are a couple definitions of that. Okay, most of the time, people will simply say it's a number in front of a variable. Okay, for in this class, that definition will work. Okay, but then when we go to Math 108, when we start solving equations, then this coefficient actually has a better definition for it. Okay. So if you right now, if you just think coefficient is a number in front of a variable, that will be fine. Later on, when in Math 108, we will redefine this word again. Okay. So when we actually combine like term, when we actually add and subtract, we only add and subtract coefficient and do nothing with the exponents. Okay, the exponents is what I use to identify the like terms. So I cannot add my exponents and having some of the numbers. Then that would not make any sense of having a different exponent than what the problem started with. Okay, so if you ever accidentally add the exponent or subtract the exponent, you're probably thinking about multiplication and division, okay, of variables. But that's not what we're doing here. What we're doing here is combining terms, okay? Add and subtract like terms. So real quick, 3y plus ay. A lot of students see variable, they start freaking out. No, don't freak out. So just like right here, I'm put on the side, okay? What is 3 circle plus 8 more circle? How many circle would you have? 11 circles, right? So here, 3y plus 8y means you have 11y. That's all it is. Okay, both terms are like terms, right? Both terms has used the same variable and the same exponent, so I can combine them. All right, 3x minus 1 plus x. So let's separate our terms. Okay, my first term got to be 3x. My second term is negative 1. My third term is positive x. So the like terms are 3x and positive x. Positive how many x? Positive what? 1x, right? Because every number is always times 1. So is any real numbers. Any real number a is always 1 times a. So if you have an x, it's literally saying 1 times x, which is 1x. Okay, so it was 3x plus 1 more x, 4x. So the negative 1, that term has no like term to combine. So we just still write it down. There's a negative 1 there. Okay, so if they're not like terms, you cannot combine them. Okay, so what do? You just put it right next to it. You just write them all out. X plus y plus 2x minus 3y. So my x is like term with positive 2x, right? So when we combine them, we normally go alphabetical order. When we combine them, we say this is 1x plus 2x, which will give me 3x's. Combine like terms, positive 1y, negative 3y can be combined. So when we combine them, you simply say this is 1 minus 3. So what's 1 minus 3? Terms with different sign, we will what? Subtract. So that's negative 2y. Because I got more negative than positive. Okay, that's all it is. Trust me, there's a lot of different ways to do this. I have seen students do this problem like this. They rearrange the terms. They swap the order and have them all lined up nice and pretty, then combine them. You don't have to write extra lines because once you identify the terms, you know who are the like term. You can go ahead and combine them. It just normally we combine them. We go by alphabetical order. So remember we said that associative property, you can add or multiply any two number first of your choice. That's basically what we're doing. We're doing associative property, which allows me to combine any two terms first of my choice. Okay, but we normally tend to go with alphabetical order. All right, negative 4a plus 2a minus 3b minus a. So let's see who are my like terms. Negative 4a positive 2a is like terms, negative 1a is like terms. So when I'm ready to combine them, I will simply say this is negative 4 plus 2 minus 1. Negative 4 plus 2 minus 1. So negative 4 plus 2 is negative 2 because it's a different term, we subtract. Minus 1, term with the same sign, we add. So now I should have negative 3a. All right, my negative 3b has no like term to combine, so I just simply write it down, negative 3b. And that's it. That's your answer, negative 3a minus 3b. They are not like term. You cannot combine them. You just have them sitting right there, right next to each other. Okay. If I got two circles plus three triangles plus two circles, then two circle and these two circle can be combined, right? Put together as one object. So that give me four circles put together. But then the three triangles are not like term are not the same thing as circles. So what do? I just put them right next to it. Okay. That's all we're doing. That's all we're doing. All right. Now we got exponents here. In this example, 3n squared, okay, is like term with who? Negative n squared. Same variable, same exponent. So alphabetical order and also go by the exponent. So the higher exponent go first. So 3n squared minus 1n squared. 3 minus 1 should give me 2n squared. Okay. Now let's go with n to the first power. 2n plus 1n. 2 plus 1. 3n. Okay. Combine like terms. Negative 5 minus 4. Term with the same sign, we add. So that should give me negative 9. And that's it. All right. Now, let's add something to this. This is another property I didn't really quite introduce before in other videos. This is called distributive property. Okay. Simplifying expression using distributive property. So it says for any real number a, b, and c. Okay. If the problem says a times parenthesis b plus c. So right now inside the parenthesis I got two terms. Okay. If I have more than one term inside the parenthesis, then I can use distributive property to bring them out, to bring my term to the outside through multiplication. So this is a times, right? So when we distribute, we say a times b, which is ab. Then we say a times what kind of c? Positive c. A times positive c give me positive ac. Okay. That's so here, the reason why we do distributive property because the two term inside are not like terms, so we cannot combine them. That's why we had to bring them out. So remember now, I said that think of the parentheses are like the grocery bag, right? Inside my grocery bag, I got two items, two objects inside of it. So when I got the grocery bag home, I'm gonna bring them out, right? You don't just take the whole entire gourd. You don't take the 2 cans of green bean or 1 can of green bean, 1 can of corn, just shove them into your pantry with a bag still on them. You take them out of the bag, right? You take them out of the bag so you can what? Combine them. All right. Same thing with the subtract version. A times B, give me AB. Then we say A times negative C. That will give me negative AC. All right. So let's check it out. Okay. Terms that need to be distributed. Okay. How do you identify the term that need to be distributed? Well, what do you got to see? You got to see parenthesis, right? And you got to see what? Multiple terms in more than one term inside the parenthesis. So in this problem, there's a plus sign and a plus sign here outside the parenthesis. So that tell me in front of the plus sign, this is one term. Positive n is another term. Positive 1 is my third term. So my first term got to be distributed because you got more than one term in the parentheses. So I will go ahead and distribute. So we say 2 times n, which is 2n. Then we say 2 times what kind of 4? You remember, I did not just say 2n minus. I did not say that. I say 2 times what kind of 4? Negative 4. 2 times negative 4 give me negative 8. Okay, and that's it. That's my first term, distribute. My next term is positive n. My next term is positive 1. So now combine like terms. My 2n and positive n are like terms. So when I combine them, I say 2 plus 1n. And that will give me 3n. Combine like terms. Negative 8 plus 1. Negative 8 plus 1 term with different sign, we will subtract. So I should get what kind of 7? Negative 7, right? Because my more negative. All right. 4a minus 3b plus 2 times a plus 2b. So two plus and minus signs outside the parentheses. So that tell me I should have 3 terms. 4a is my first term. Negative 3b is the second term. Positive 2 times a plus 2b should be the third term. So my third term got to be distributed. So I go ahead and say 4a is still 4a, right? You know what I'm saying? First term, there's nothing to do. Second term is still negative 3b. Now we say positive 2. That's how we read this. Positive 2 times a. Positive 2 times a, which is positive 2a. Then we say positive 2 times positive 2b. So when you say keep on saying that, that means we are multiplying, right? So naturally, you would just write down the correct sign. Positive 2 times positive 2b is positive 4b. All right. So combine like term. Okay. I bring out, I took out all my grocery. Now I'm going to combine them. So 4a plus 2a is 6a. Excuse me, 4b minus 3b, or you can say negative 3 plus 4 is negative 1b. Oh, something positive 1b, sorry. So you can just say 6a plus b, or if you want, you can say 6a plus 1b. You can write the 1 right here. I don't care. If you want to write a 1, that's fine. I'm totally cool with it. Some teachers don't like people write, don't like students write the 1. Not me. You can write the 1b, or you can just write the b. It's the same to me. All right. If you read this problem, 4 times parentheses x plus 5y plus 3 times, so you only say 1, there's only one plus sign outside the parentheses. Okay, so my first term, I got to distribute, right? Because this parentheses involved with more than one term. And this one is a second term, positive 3 distribute. So my first term in yellow, positive 4 times x, positive 4x. All right, positive, then we say positive 4 times positive 5y, positive 20y. Remember, every term can only have one sign. I think student wrote this before. It's minus a negative. Okay, can never write that. Every term can only have one sign. Okay. All right, let's do the second term. So that's it for the first term distributing. These are the two terms coming up. Second term, distribute positive 3 times 6x, positive 3 times 2x, positive 6x. Positive 3 times negative 7y, negative 21y. All right, let's combine like terms. 4x is like term with positive 6x. So when I'm combining them, I say 4 plus 6, which will give me 10x or positive 10x. All right, combine like terms. 20y, negative 21y are like terms. So we can say 20 minus 21. 20 minus 21, negative what? 1y, right? All right, so that's how we distribute, then combine like terms. All right, so this objective, whenever you see the word evaluate, that means we're going to do some substitution. Okay, so we're going to substitute variable for the numerical value that we are given. And once we've done that, we will simplify the expression. We'll actually figure what the numerical answer is. Okay, so the easy way to do this is just like the same way as we do order operation. Figure out how many terms you have. So by look at this problem, you know there are three terms. Okay, so in a minute we will just, in a bit we'll just evaluate one term at a time and then do all together, see what the final answer is. So this is 5x, right? So I need to substitute x for negative 3. So 5x means 5 times x. Now the 5 will now times, not x anymore because I'm replace x with negative 3. So we will substitute negative 3 for x. Oops, sorry. So now the 5 will times negative 3. All right, second term, negative 9 times y. Now replacing y with 2, so that'll be negative 9 times 2. So whenever I'm substituting, I always put those numbers in the parenthesis. Last term is just negative 2. Okay, so do one term at a time. So my first term, 5 times negative 3 is negative 15. My next term, negative 9 times 2 is negative 18. My last term, no operation, still negative 2. So now the problem actually reads as negative 15 minus 18 minus 2. But when we actually combine them, we see them as individual terms. So it's easy for us to add and subtract. So I'm going to combine the last two first, okay? Negative 18 and negative 2 combined. Term with the same sign we add. So that gives me negative 20. And negative 15 still up front, right? And I got the last two give me negative 20. So terms with the same sign again, I will add. So that will be negative 35. All right. Now this one's a little bit tricky, okay? This one has got a little bit of, it's got some exponent in it. So we definitely got to use that parenthesis. So this expression, again, three terms. The first term is negative 5x squared, or you can say negative 5 times x squared. So negative 5 times, now I'm replacing x with 2, but don't forget the exponent is still on the outside, right? On the outside the parenthesis, because it was on the outside the x, so now it's going to be on the outside the parenthesis, because I'm replacing x, right, with a 2, and I put that 2 in the parenthesis, so the exponent got to be on the outside. Second term, negative 9 times y squared. Now I replace y with negative 1. So that will be negative 9 times negative 1 squared plus 2. So again, one term at a time, okay? Remember this negative 5x squared was the first term. Negative 9 times negative 1y squared was the second term. Okay, so we do one term at a time. So first term, exponent first. 2 times 2 is 4. This 4 will times the negative 5, which is negative 20. Be very careful here. Negative 1 whole thing squared first. Negative 1 whole thing squared means negative 1 times negative 1, which is positive 1. That positive 1 times negative 9 will be negative 9. Right? Negative 1 times negative 1 is positive 1. Positive 1 times the negative 9 in the front for that term is negative 9 plus 2. All right. So negative 20 minus 9 is negative 29. Term with the same sign we add, plus 2. Term with different sign we will subtract, so that would be negative 27. That would be the answer. Okay, so I'm gonna go over the homework here, especially with entering the exponent. I want to make sure y'all remember this. So I'm gonna go to our class in D2L. So this is logging, and I got a lot of class here. This is our class. This is topic number 19, I think. Quizzes. So mine look a little bit different than yours. It's okay. I'm gonna preview. Start. Okay. All right. When combined like terms, add and subtract both coefficient and exponent of the variable. When combined like terms, we're gonna add and subtract both the coefficient and the exponent of the variable. True or false? False, right? Because when combined like terms, we only add and subtract coefficient and do nothing with the exponent. So that'll be false. All right. For this problem, tell me how many terms you see. It's multiple choice. All right. This problem right here. Simplifying the following operation. Okay, so I want to remind you, you have seen this three steps a lot. So every time when you see this 3-step, you got to use the graphic equation. So real quick, the positive 2x squared and positive 3x squared are like terms. So that should give you positive 5x squared. So that will be your first term, 5x squared. So just want to show you how to enter this. So the show all components, graphic equation. So the answer is 5x squared first, right? So that's 5. I type in x. Then I choose this one. This is your exponent. So input 2. So right now the cursor is on the top. So to enter the next term, you press the right arrow key on the keyboard to come down, and then you enter rest of your answer. Okay, whatever the rest of the answer is. All right. So this one, simplifying this expression and enter your answers. Okay. And this is a evaluating. So you just enter your final answer here using the 3-step, just like we did. So just real quick, showing you how to simplifying algebra expression by combine like terms and using distributive properties to bring out the terms outside the parentheses so we can actually combine them. So one more thing before I end this video, I want to go back to um, maybe a problem like this one right here. I'm gonna just write it like this. Okay, for example, if I have this problem as 2 times not n minus 4, but 4n plus n plus 1. This first term, do I need to do distributive property? No, because this is only one term inside the parenthesis. So this is not a distributive property. This is simply 2 times 4n, which is 8n. Okay, because there's only one term in there. So by having a subtraction sign in the parenthesis, if you look at all the problem we do distributive properties, inside the parenthesis is always more than one term. Okay, so we bring those terms out. If inside the parenthesis has 3 terms, then the distributive property gotta be done. You gotta bring out all 3 terms. You gotta multiply all 3 of them. Okay, so these examples are only 2 term inside. If there is another term inside, you bring them all out. If inside the parenthesis is only one term, then you don't have to do distributive property. You just simply multiply. Okay, thank you for watching.